Every type of sensor explained. Temperature sensor. Temperature sensors are devices designed to measure how hot or cold an object or environment is. They work by detecting changes in heat and converting those changes into electrical signals that a system can understand. Different types of temperature sensors include thermistors, thermocouples, and resistance temperature detectors. They are found in air conditioners, refrigerators, medical equipment, smartphones, and industrial machinery. Without temperature sensors, many systems would overheat, become inefficient, or fail completely. Their ability to monitor and regulate heat makes them one of the most important sensors used in modern technology. Pressure sensor. Pressure sensors measure the force exerted by liquids or gases and convert that force into useful electrical data. Most pressure sensors use a flexible diaphragm that bends slightly when pressure changes. This movement is then translated into an electronic signal. Pressure sensors are commonly used in vehicle tire monitoring systems, hydraulic machinery, aircraft systems, and industrial pipelines. Maintaining the correct pressure is essential for safety, efficiency, and performance. By constantly monitoring pressure levels, these sensors help prevent equipment damage, improve reliability, and ensure systems operate within safe limits. Proximity sensor. A proximity sensor detects the presence of an object without making physical contact. Depending on the design, it may use electromagnetic fields, infrared light, or ultrasonic waves to sense nearby objects. These sensors are widely used in manufacturing automation, smartphones, automatic doors, and robotics. Because they do not require physical contact, they experience less wear and tear and often last longer than mechanical switches. Their ability to quickly and reliably detect objects makes them valuable in environments where speed, precision, and durability are important. Infrared sensor. Infrared sensors detect infrared radiation, a type of energy emitted as heat by all objects. These sensors can measure temperature, detect movement, or transmit signals between devices. A common example is the remote control used for televisions and other electronics. Infrared sensors are also widely used in security systems, where they detect changes in heat patterns caused by moving people or animals. Since they can operate effectively in darkness and detect invisible infrared energy, they are highly useful for monitoring, automation, and communication applications.
Ultrasonic sensors. Ultrasonic sensors measure distance using high-frequency sound waves that humans cannot hear. The sensor emits a sound pulse and waits for the echo to return after bouncing off an object. By calculating the travel time of the sound wave, the sensor determines the object's distance. These sensors are commonly used in vehicle parking assistance systems, robotic navigation, water level monitoring, and industrial automation. Because they do not rely on visible light, ultrasonic sensors can work effectively in dusty, dark, or smoky environments where optical sensors may struggle. Light sensors. Light sensors detect and measure the intensity of light in their surroundings. They often use components such as photodiodes or photoresistors, which change their electrical properties when exposed to light. These sensors are found in smartphones that automatically adjust screen brightness, as well as in smart lighting systems that turn lights on or off based on environmental conditions. Light sensors help save energy and improve user comfort by allowing devices to respond automatically to changing light levels. Their simplicity and effectiveness make them extremely common in everyday electronics. Humidity sensor. Humidity sensors measure the amount of water vapor present in the air. They typically work by detecting changes in electrical resistance or capacitance caused by moisture absorption. These sensors are widely used in weather stations, greenhouses, air conditioning systems, and industrial storage facilities. Monitoring humidity is important because moisture levels can affect human comfort, agricultural productivity, product quality, and equipment performance. By providing accurate humidity measurements, these sensors help maintain optimal environmental conditions in both residential and industrial settings. Gas sensor. Gas sensors are designed to detect the presence and concentration of specific gases in the environment. They work by measuring chemical reactions or electrical changes that occur when gas molecules interact with the sensing element. Common applications include carbon monoxide detectors, industrial safety systems, and environmental monitoring equipment. Gas sensors play a crucial role in preventing dangerous leaks before they become hazardous. Their ability to provide early warnings helps protect people, equipment, and facilities from potentially life-threatening situations.
Motion sensor. Motion sensors detect movement within a defined area. Depending on the type, they may use infrared energy,
microwave signals, or vibration detection techniques. Motion sensors are commonly used in security systems, automatic doors, and energy-saving lighting systems. When movement is detected, the sensor can trigger alarms, activate cameras, or switch on lights. Their ability to respond automatically to activity improves convenience, enhances security, and reduces energy consumption. Motion sensors have become an essential part of smart homes and modern automation systems. Accelerometer. An accelerometer measures acceleration, movement, and changes in orientation. It contains tiny internal structures that move when the device experiences acceleration. This movement is converted into electrical signals that indicate speed, direction, or tilt. Accelerometers are found in smartphones, fitness trackers, drones, gaming controllers, and vehicles. They enable features such as screen rotation, motion tracking, and crash detection. By providing precise information about movement, accelerometers help devices understand how they are being positioned and used. Gyroscope sensor. A gyroscope sensor measures rotational movement and angular velocity. Unlike an accelerometer, which detects linear motion, a gyroscope focuses on rotation and orientation. These sensors are commonly paired with accelerometers to create highly accurate motion tracking systems. Applications include drones, virtual reality headsets, gaming controllers, smartphones, and aircraft navigation systems. By detecting even small rotational changes, gyroscopes help maintain balance, improve navigation accuracy, and enhance user experiences in interactive technologies. Magnetometer. A magnetometer measures magnetic fields and is often used as a digital compass. It detects both the strength and direction of magnetic forces in the surrounding environment. In smartphones, magnetometers help determine the device's orientation relative to the Earth's magnetic field. They are also used in navigation systems, geological surveys, and industrial equipment. By providing precise information about movement, magnetometers support accurate navigation and positioning in a wide range of applications, from consumer electronics to scientific research. Touch sensor. Touch sensors allow machines and electronic devices to detect human contact. Depending on the technology used, they may sense pressure, electrical conductivity, or changes in capacitance. Touch sensors are the foundation of modern touchscreens found in smartphones, tablets, kiosks, and appliances. They provide a simple and intuitive way for users to interact with technology. Their reliability, responsiveness, and ease of use have transformed the way people control and communicate with electronic devices.
Image sensor. Image sensors convert light into digital information, enabling cameras and vision systems to capture images and video information. They contain millions of tiny pixels that respond to incoming light and record brightness and color information. Image sensors are used in smartphones, digital cameras, security systems, autonomous vehicles, and robotics. Their ability to capture visual data allows machines to observe and interpret the world around them. As image sensor technology continues to improve, cameras become more detailed, intelligent, and capable. Force sensor. Force sensors measure the amount of force, pressure, or weight applied to an object. Most force sensors use strain gauges that change electrical resistance when stretched or compressed. These sensors are commonly found in weighing scales, industrial testing equipment, robotic systems, and structural monitoring applications. By accurately measuring force, they help engineers evaluate performance, ensure safety, and maintain quality standards. Their role is critical in industries where precise load measurements are required. Sound sensor. Sound sensors detect audio waves and convert them into electrical signals. Most contain microphone elements that respond to vibrations in the air. These sensors are used in voice-controlled assistants, smart devices, noise monitoring systems, and security equipment. Sound sensors allow machines to react to spoken commands, environmental sounds, or changes in noise levels. Their ability to bridge the gap between human speech and machine understanding has made them increasingly important in modern technology. Flow sensor. Flow sensors measure the movement rate of liquids or gases through a system. They can use rotating turbines, thermal methods, or pressure-based techniques to determine flow speed and volume. Flow sensors are essential in water distribution systems, fuel management, chemical processing, and industrial automation. By monitoring flow rates, they help improve efficiency, reduce waste, and ensure proper operation of complex systems. Accurate flow measurement is critical in many industries where precise control of fluids is required.
Optical sensors use light to detect the presence, position, or characteristics of an object. They operate by analyzing reflected, interrupted, or absorbed light beams. These sensors are commonly found in barcode scanners, manufacturing equipment, and quality control systems. Optical sensors are valued for their high speed, accuracy, and reliability. Because they can detect very small changes, they are widely used in applications where precision is essential. Biosensor. Biosensors combine biological components with electronic systems to detect specific biological or chemical substances. They often use enzymes, antibodies, or living cells to recognize target molecules. One of the most common examples is the glucose monitor used by people with diabetes. Biosensors are transforming healthcare by enabling rapid diagnostics, continuous monitoring, and personalized treatment. Their ability to provide real-time biological information is driving major advances in medicine and biotechnology. Capacitive Sensor. Capacitive sensors detect changes in electrical capacitance caused by nearby objects or materials. They can sense both conductive and non-conductive objects, making them highly versatile. Capacitive sensors are commonly used in touchscreens, liquid level measurement systems, and proximity detection applications. Their sensitivity allows them to detect objects through non-metallic surfaces, such as glass or plastic. This flexibility has made them a popular choice in consumer electronics and industrial automation. Inductive Sensor. Inductive sensors are designed specifically to detect metallic objects without physical contact. They create an electromagnetic field and monitor changes caused by nearby metal. These sensors are widely used in industrial automation, conveyor systems, and machine positioning applications. Because they contain no moving parts and are resistant to dust, moisture, and vibration, inductive sensors are highly durable and reliable. Their ability to perform consistently in harsh environments makes them a trusted solution for industrial sensing tasks.